Subscribe to our YouTube channel. Press the bell icon on the YouTube app and never miss another update from Educare Classes. बेल आइकन को दबाइए और एडुकेयर क्लासेस की सारी नोटिफिकेशंस पाइए. एडुकेयर क्लासेस, we create gems from stones.
Hello students, our question is, an infinite ladder is constructed by connecting several sections of 2 microfarad, 4 microfarad capacitors. Combinations are shown in figure. It is terminated by a capacitor of capacitance C. What value should be chosen for C such that the equivalent capacitance of the number of sections in between? So as per the question, the question says that we have two capacitances, 2 microfarad and 4 microfarad, which forms an infinite ladder, and this infinite ladder is terminated by using this capacitance C. So we can say that if we terminate whole section, this capacitance will be equal to, the capacitance will be equal to C. Now if we redraw this figure, we can say that this is point A and this is point B. So here we have a 2 microfarad capacitor, and here we have a 4 microfarad capacitor, 4 microfarad capacitors, and the whole network or section is being terminated by this capacitance C. Now what will happen if we want to terminate this section? Then the capacitance of this section will be equal to C. Now as per the figure, we can clearly see that this C capacitance and 4 microfarad are in series. When two capacitances are connected in series, we can say that this is capacitance 1 and this is capacitance 2. So C1 and C2 are connected in series. So net series capacitance will be equal to C1 C2 upon C1 plus C2. In this case, let us say that the net series capacitance is C1, which is equal to 4C upon 4 plus C. 4C upon 4 plus C. So we have series capacitance. Now when we redraw this figure, this is point A, this is point B, this is 2 microfarad, and this is capacitance C1. Now this whole capacitance is equal to C. When two capacitances are connected in parallel, we say that the net capacitance is equal to C1 plus C2. So we can say that 2 microfarad and C1 are parallel. If these two capacitances are connected in parallel, we can say that the net capacitance, which is equal to C, is equal to C1 plus 2. So we can write it here as C is equal to, C1 is 4C upon 4 plus C plus 2. Now when we solve this will be equal to 4C plus C square is equal to 6C plus 8, which we can write it as C square minus 2C minus 8 equal to 0. So our quadratic equation is C square minus 2C minus 8 equal to 0. We can solve it by using a quadratic formula or by middle term splitting. Now when we middle term split this equation, it will look something like this: C square minus 4C plus 2C minus 8 equal to 0, which we can write it as C minus 4 into C plus 2 equal to 0. This will give the value of C as 4 microfarad or minus 2 microfarad. Since capacitance can't be negative, so we will eliminate this value. So what will be the value of C? The value of C is equal to 4 microfarad. The value of C is equal to 4 microfarad. So you will need a 4 microfarad capacitance. You will need a 4 microfarad capacitance, so that what you can do, so that you can terminate the whole section. You can terminate the whole section. So this 4 microfarad is our answer, is our answer as per the question, as per the question. I hope this cleared your doubt. Thank you.